In this skills review, we're going to begin looking at rational numbers, and there will be a couple of lessons in total on rational numbers. And in case you're wondering what they are sometimes known as fractions. Okay, the formal definition, um, let me just move that cursor out of the way that's distracting me there. Um, the natural numbers, whole numbers, and integers, we were able to list those as a set using brackets and ellipsis, the dot, 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 which we mean, which we usually think of as meaning etc. We could list all those other number sets that we looked at so far, but you can't list all the rational numbers. So instead, we need to use a definition, and the definition of rational numbers is the set of all numbers that can be expressed in the form a over b or a divided by b, where a and b are integers and b does not equal 0. And recall that piece from what we looked at earlier when we looked at dividing by 0. So we can never have 0 in the denominator because denominator is always what's being divided by. So some examples of rational numbers. Well, 3/4 would be an example, but so are these other examples. These are all rational numbers because even though they aren't all written like a fraction, they all can be written as fraction. So 3/4 is already looking like a over b. 0 isn't yet, but it could be written as 0 over 7. 0 divided by 7 is 0. 5 could be written as 5 over 1. So long as I have an integer in the numerator and denominator, and the denominator is not equal to 0, the number is a rational number. And 1.75 could be written as 175 1/100ths, or some of you may want to write that as 1 3/4. Okay, both are of the same value, and both are sort of fractional representations of the rational number 1.75. So the first thing we need to practice with is reducing rational numbers, and that's done by dividing the numerator and denominator by a common factor. Remember, the number on the top is the numerator and the number on the bottom is the denominator. So 15 over 65 or 15/65. One way we could do that, excuse me, that went back to a thick line and I prefer to write with a thin line. One way we can think of that is think about what's the common factor, what goes into 15 and into 65, and you might recognize that those are both divisible by 5. So this is 3 times 5, and the denominator is 13 times 5. So if we divide out that common factor, we end up with 3/13. Okay, the other way to think about it, and this is just a slightly different way of thinking about it and might seem more familiar to some of you, we can think of it as 15/65 is equal to, and I'm going to divide the top by 5, divide the bottom by 5. And sometimes you wrote those divide by 5s really tiny next to it to show that you're dividing top and bottom by 5, and you end up again with 3/13. So whether you think of it as removing a common factor like the first example, or dividing by the common factor in the second example, both of those methods work. And in case you're thinking, do I actually have to show that step? The answer is no. But you do need to remember that in any type of problem that we encounter, our final answer always needs to be in its most simplified form. And with rational numbers or fractions, the simplified form is reduced to lowest terms so that there's no common factor left in the numerator and the denominator. So the second question here, it looks like we could factor out a 5 from the numerator and the denominator. So if we do a little bit of math either in our heads, or we might have to pull out a calculator to do that, we'll see that we've got 26 times 5 and 91 times 5. So once we divide out those two 5s, we end up with 26 over 91. Now those are not numbers that are easy to see, especially the 91. It's not easy to think of everything that goes into 91. But you might look at the 26 and see that 2 goes into it. How many times does 2 go into 26? 13 times. So let's see if 13 goes into 91. And again, if you have to use a calculator, do, but then check, does 13 go into 91? And yes, it does 7 times. So we can rewrite the 26 over 91 as 2 times 13 and 7 times 13. So now those common factors are divided out and we're left with 2 over 7 to get the reduced form. Okay, so when you have challenging numbers to know whether there's a common factor or not, just look at the factors of the one of them and then check if those factors are also factors of the second number. Okay. All right, and our next step is going between mixed number form and improper fraction form. And there's nothing improper or wrong about improper fractions. It's just a way of writing a fraction so that the numerator happens to be larger than the denominator. So in the second example, that 7 over 2 is considered an improper fraction, but there's nothing wrong with it. And in fact, often it's preferable. If I tell you I need 5 3/4 cups of sugar, it's easy to envision. If I tell you I need 7/2, it's less easy to envision. So when you're thinking about the amount of something, the mixed number might be preferred. But if I actually have to multiply or divide the fractions, I really want to have them in improper fraction form so that they're easier to work with. So you need to be able to flip between the two methods. So there's a couple of ways of doing that. And if we think in terms of pizzas, which is really easy to do when you're dealing with fractions or when you're hungry, if I have 5 whole pizzas and 3/4 of a pizza, I can think about, well, what if happens if I turn that all into quarters? So if I cut all the pizzas into quarters, I now have, how many quarters do I have? Well, I've got 4, 8, 12, 16, 20, and 3 more. So that gives me 23 quarter pizzas. Okay, so that's, if you're visual, you may find it helpful to draw that. If you just need to learn a little rule to remember, the rule is the denominator stays the same and your numerator becomes 5 times 4 plus 3. And so we end up with 23/4. Okay, if you look at where that 5 times 4 comes from, it's very easy to see that that's from the 5 whole pizzas, each split into quarters. So both methods are the same. And so if drawing a picture helps you better, or if memorizing a rule works better for you, choose one or the other to do the conversions. Then if you are working from an improper fraction and need to switch that to a mixed number, you might start thinking, well, these are halves in the denominator. So if I have half a pizza and another half of a pizza and another 2 halves and 2 more halves, notice I'm kind of squishing those halves together to make whole pizzas. So that's 1, 2, 3, 4, 5, 6 halves, and I need 1 more half of a pizza. I now have 3 whole pizzas and 1 half pizza. So 3.5. Or I can do this. The little rule to remember would be 7 divided by, remember that horizontal line means divide. So 7 divided by 2 is 3 with a remainder of 1. So it gives me 3 and 1 half left over. Okay, so there's the 3 whole pizzas and the 1 half left over. Notice that in both methods, when I'm going from mixed to improper or from improper to mixed, in both cases, the denominator stays the same. Okay, so you're still dealing with, in the first example, we were dealing with quarters both times, both methods, both representations, whether we were working with the mixed number or the improper fraction, both of them are dealing with quarters, okay? And in the second example, both the improper fraction and the mixed number, we're still talking about how many halves that we have, okay? And that's it for this little quick introduction to fractions and rational numbers.